Hello students, welcome to the topic matrices. In last video, I discussed about the multiplication of matrices. In this video, I am going to solve examples on product of matrices. Now see the first question. If A is equal to matrix 1, 1 minus 1, 2, 0, 3, 3 minus 1, 2, B is a matrix 1, 3, 0, 2, minus 1, 4, and C is a matrix 1, 2, 3 minus 4, 2, 0 minus 2, 1. Then prove that A into BC is equal to AB into C. That means for the given three matrices, you have to verify associative law. Now see the solution. In this example, given that A into BC and AB into C. So first let me find LHS term, that is A into BC. For that, first you operate first BC term. So BC is equal to B matrix, substitute, and into C matrix, that is 1, 2, 3 minus 4, 2, 0 minus 2, 1. Already you learned that how to multiply two matrices. It is operated row into column wise. So here we have 4 columns. That means in the first row of the product we get 4 elements, remember. So that is equal to matrix, first row, first column, elements are multiplied and added. That is 1 into 1 plus 3 into 2. So next column elements 1 into 2 plus 3 into 0. So we have another column, therefore operating with the third column 1 into 3 plus 3 into minus 2. So one more column is there, that is the fourth column. So with that if I operate, I will get the elements like this: 1 into minus 4 plus 3 into 1. Remember students, in the second matrix, how many columns you will get? No, so that much elements you will get in the product of the matrix. And here in the first matrix, how many rows are there? That much rows you will get in the product of the matrix. This is very important. Okay, now first row with all columns, it is operated. Now the second row and with the columns, same way you operate. That is the second row with the first column elements. Elements are multiplied and added. That is 0 into 1 plus 2 into 2. Okay, next column, second one, 0 into 2 plus 2 into 0. Okay, next third column, 0 into 3 plus 2 into minus 2. Next fourth column, 0 into minus 4 plus 2 into 1. All 4 columns are completed. So next third row with the first column elements, we have to operate minus 1 into 1 plus 4 into 2. Next column, second column, minus 1 into 2 plus 4 into 0. Next third column elements, minus 1 into 3 plus 4 into minus 2. Next fourth column elements, minus 1 into minus 4 plus 4 into 1. So all columns are completed, as well as in the first matrix all rows are completed. Therefore this completes the matrix product. This BC. So next is a simplification. So you will get 1 plus 6, and here 2 plus 0, 3 plus minus 6, and minus 4 plus 3. So second row elements, it is a 0 plus 4, it is a 0 plus 0, next 0 plus minus 4, and last element 0 plus 2. Next third row elements, it is a minus 1 plus 8, minus 2 plus 0, minus 3 minus 8, and 4 plus 4. Next step, adding the numbers, you will get 7, 2, minus 3, and this is minus 1. Next row, it is 4, 0, minus 4, 2. Third row elements, 7, minus 2, minus 11, 8. So this is the BC matrix. I hope you understood how to multiply B and C matrix. So now let me take LHS term, that is A into BC. So that is equal to, substitute A matrix and BC matrix. Now you find the multiplication of these two matrices, that is following definition of multiplication, that is row into column wise. So that is equal to first row elements into first column elements. We have to multiply and add, then you will get value 4. So here it is operated directly and return the value 4 directly. In the same way, with the second column elements, if you operate, you will get 4. With the third column elements, again you will get 4. Now last column elements, if you operate, you will get minus 7. So this gives the first row elements of the multiplication. So now to get the second row elements, we have to operate second row with first column elements. Therefore second row elements and first column elements are operated, and operate, you will get a value 35. And with the second column elements, if you operate, you will get a minus 2. And with the third column elements, you will get minus 39. And last column elements, with this if you operate, you will get 22. So these are the second row elements. Now to get the third row elements, and with the first column elements you have to operate. So when you operate, you will get 31. And with the second column, if you operate, you will get a 2. And with the third column, if you operate, you will get minus 27. And with the fourth column elements, if you operate, you will get 11. So this is LHS matrix, that is A into BC matrix. You take this as equation 1. Now you find out AB matrix. Now A matrix substitute into B matrix. Again, by the definition of product, first row, first column elements are multiplied and added. If you operate that one, you will get a value 2. And with the second column, if you operate, you will get 1. And second row is taken, therefore second row elements are written. With the first column, if you operate, you will get minus 1. And with the second column, if you operate, 18. So this is the second row elements. Now to get the third row elements with the first column elements, we have to multiply and we have to add. So we get 1. And with the second column elements, if you operate, you will get a 15. And this is the product AB. So now consider RHS, that is equal to AB into C. So already AB matrix we know it is a 2 1 minus 1 18 1 15 and into C matrix. So again by the definition of multiplication, row wise into column wise elements are multiplied and added. So if you do that operation you will get a 4, and with the second column elements if you do the same operation you will get a 4, and with the third column elements if you operate you will get 4, and with the last column elements if you operate you will get a -7. Next two elements are written by following second row elements with the first column elements operating. You will get a 35, and with the second columns if you operate -2, and with the third column you will get -39, and with the fourth column elements if you operate you will get 22. So this completes second row elements. Now to get the third row elements, third row elements and first column elements are operated. So then you will get a 31, and with the second column elements if you operate it is a 2, and with the third column elements if you operate you will get -27, and with the fourth column elements if you operate you will get 11. So this is the now RHS matrix, that is AB into C. You take this as equation 2. Now this equation 2 and 1 both are same matrices. Therefore from equation 1 and 2 LHS is equal to RHS. That means A into BC it is equal to AB into C, which means that associative law holds. I hope you understood how to find AB matrix and AB into C matrix and BC matrix and A into BC matrix. Now see the second question. If A is equal to matrix 1 0 2 0 2 1 2 0 3, then prove that A cube minus 6A square plus 7A plus 2I equal to O. So as I discussed in the previous video, so square or cube of the matrices we have to find out multiplying the matrices A 2 times and 3 times respectively. To find the A cube, A square is required. Therefore, first we operate A square matrix. So A square is equal to A into A. So that is A matrix substitute 1 0 2 0 2 1 2 0 3, and same matrix 1 0 2 0 2 1 2 0 3. So by following the definition of product, row into column wise elements are operated. So you will get a 5 when first row elements with the first column elements if you operate that rule, that is a multiplied and added, you will get a 5, and with the second column elements if you operate you will get a 0 number, and with the third column elements if you operate you will get a 8, and we have second row, therefore second row elements are given by second row elements. First row elements we have to operate, then you will get 2, and with the second column elements if you operate that is 4, and with the third column elements if you operate you will get a 5. Now we have third row, therefore third row with the first column if you operate you will get a third row elements, so you will get 8, and with the second column you will get a 0, and with the third column elements if you operate you will get a 13. So this is A square matrix. Now I'm finding a cube. A cube means a square into a. So substitute a square matrix and a matrix. So again following the product row into column wise, that is the first column. If you operate, that is multiplied and multiplied the elements, and if you take the sum, you will get a 21. And with the second column, if you operate, you will get a 0. And with the third column, if you operate, you will get a 34. Now second row elements, with the first column, if you operate, you will get a first element of the second row, that is 12. And second column, 8. And with the third column, you will get 23. Second row elements are completed. Now third row we have, therefore third row elements are written operating with the first column, that is 34, and operating with the second column you will get 0, and operating with the third column you will get a 54. So this is a cube matrix. Now consider LHS. A cube minus 6a square plus 7a plus 2i. That is equal to, substitute a cube matrix minus 6 into a square matrix plus 7 into a matrix plus 2 into identity matrix. Here, dear students, remember always identity matrix, it is of order same as whatever the order A matrix is having. That is 3 order. If A is a 3 order means I is also 3 order. If A is a second order square matrix means I should be 2 order. So next a cube, that is 21 0 34 12 8 23 34 0 55 as it is, minus this is now multiplied by 6. So when you multiply it by 6 you will get 30 0 48 12 24 30 48 0 78 plus now 7 into this matrix. So you will get 7 0 14 0 14 7 and 14 0 21 plus now 2 is multiplied, therefore it is a 2 0 0 0 2 0 0 0 2. Now operating this entire matrices, here we have minus, here we have plus, and here plus. So position wise elements are taken, first 21 and here we have minus, therefore this minus 30, and here it is plus 7 and plus 2. So all first position elements are taken. Next all second position elements, first one is 0, minus 0 and plus 0 plus 0. Now third position elements 34 minus 48 and plus 14 plus 0. So like this all position elements are written, 12 minus 12 plus 0 plus 0, 8 minus 24 plus 14 plus 2. Next element 23 minus 30 plus 7 plus 0. Next third row elements, first element 34 minus 48 plus 14 plus 0. Next element 0 minus 0 plus 0 plus 0. Next last element 55 minus 78 plus 21 plus 2. So next simplifying this you will get 0 0 0, all elements you will get a 0. That means this matrix is denoted by O, which means that we got a cube minus 6a square plus 7a plus 2i as 0 matrix. So that means we proved that this expression gives you 0 matrix. I hope you understood how to find out a cube matrix, a square matrix, and how to get the zero matrix. I hope you understood the examples whatever solved in this video. Thank you, students.